My name's Wayne Callan. The drawing we're looking at is the final subcircuit arrangement within the multiple earthing neutral M.E.N system of earthing. We've called it drawing A, as you can see down here. And so this is a typical layout of the M.E.N system across three houses. So we've got three houses, one on each phase. So if you look, you go right up the top up here, we've got house 1 and it's on A phase. And then when we come across, we've got house 2, that's on B phase. And then house 3 is on C phase. So where it's typically balanced across a three-phase TNCS earthing system. So over here we can see that the earthing system that we use in Australia is a TN earthing system, and from that we have three different types of TN systems. And type A is this one here, where we've got, it's a TNS, and so the beauty of this one is you've got your line active across the top there coming out of your transformer, you've got your neutral down here coming out, and then you've got a separate protective earth down to your equipment. And then in type B, which is your TNC, from your transformer you've got your live active, then you've got your neutral and your earth are combined, and that's what the C says, it's combined, so it's a PEN down to your equipment. And then you've got type C, which is TNCS, and this is the common one that we use in Australia. So the TNCS uses the line active, then you've got your neutral, and off that you've got your protective earth as a combined and a separate. See, there's the combined coming down to the equipment. Now that goes all the way to the equipment. Then you've got your separate earth coming across here as a separate earth down to the equipment as well, and there you've got the active. So when we come back over here, say to house 1, you've got your active and neutral coming in, and so there's only two, typically it's two cables, two separate cables that come in. It's an active and a neutral, so it's, as in this zone it says, it's a TNC, because your neutral and your earth are combined as they come into your switchboard. And so we can see that the active comes in and goes down through your service fuse, down through your metering, down through your main switch, all the way to your RCD, then to your final subcircuit, out to your power point. And it's at the power point that it reaches the TNCS. So we'll go back up the top and we look at the neutral. The neutral's a TNC, and so it comes down, goes down to the neutral link, it comes down to the consumer neutral link, and then all the way through the RCD down to the final subcircuit to the neutral. And it's here in this yellow zone that we have up here that we've got the TNC zone is what we've termed this as. And this is for the availability of supply. So typically it's to keep the supply going. So the TNCS, which is for your basic safety, comes off where the earth, which is green, it's not like the blue of the neutral, it goes down to your main earth. And then it goes from your main earth down to your earth stake, all the way down here to the ground. Then it goes over to your water pipe bond, your taps, your gas, whatever copper piping that you've got in your house, and it's in what we call the TNC S zone, which is this red zone, as we call it. Goes all the way around here, and this is called true earth. So it's the basic connection to outside true earth, through your water pipe, through your gas pipe, through your earth stake. And they're the three connections that you've got. And that gives you the multiple earthing of the neutral. So, and obviously then in the final subcircuits, we've got this one that comes down, down to your earth point on your final subcircuit. So we look over here in house 2, and it's slightly different. So we've got our mains coming in at the top. We've got I've got the red active going all the way through to the service fuse down to the final subcircuit with the power point through the RCD and everything like that. But you take the neutral, which is, you can see across the top, this is the transformer link. So at the transformer, the TNC is linked all the way between the 3 houses, straight across there like that. You can see how they're all linked back, where the actives, because they're on different phases, it's separated. So in this one, we've got the yellow zone. This is house 2 on B phase, and the yellow zone is exactly the same as house 1, and it's again availability of supply. And we come down here, we've got the TNCS link, which is called the M.E.N link, down to the main earth. But look, if you look at it, there's no copper piping. And this is a change that's happened to the electrical standards since about the early 1990s, where polybutylene is replaced copper piping for the taps, the gas, all your earthing arrangements, and gal piping is now it's PVC. So effectively, you've got your TNCS zone, which is over here, your basic safety zone. Now it's in island mode, because you've only got one external earthing point, and this is this one that comes down to your earth stake. So this is what we call island mode. There's no earthing points inside your house. And this is current housing that has been around for 20-something, years. And so you've got it changes the dynamics of the RCD. So instead of having like your wet areas like your laundry, your bathrooms, your kitchens, instead of having your taps, your sinks, your baths, and all your ground water waste points, they're all changed. Like wet areas now cover any of the concrete flooring that you have underneath your tiles. So we go over to house 3, and we can see it's exactly the same, but this one's got a solar, and so we're sort of added the solar just because it could, it's a modern, renewable energies are an emerging, dynamics that will happen, and so we've thrown that into house 3, and again we've got the TNC, which is the availability of supply. We go through the whole, look at it. We've got the TNCS M.E.N point down, and again there's no copper piping, so it's the basic island mode. Which then, if we go over to here and we look at our notes, and we can see that note 1 says a fault can appear on all 3 houses through the TNCS earthing system, which is the M.E.N system. Because as you look down here, you can see that the earth stakes are in the ground. And so a fault here could travel across this, earth path, back up this one. See the arrow there? It's pointing up. It can go up that, back up to the neutral link, up through there, all the way back up to your main neutral. And it's exactly the same with all 3 houses. You can go through here, an earth on H2 fault will put a voltage rise on house 3 and house 1. So we look at this note 2, which says a fault on house 3, the solar can supply a dangerous voltage rise on houses 1 and houses 2, because up here, because it's up this end, and the solar will have a TNC coming, isolated, because it's a auxiliary supply, but then they earth it, and they run the earth down to your main neutral, or your main earth, sorry. And then so you can get, if you have a fault on your solar, which is your solar rooftop fires, then that problem is going to go all the way down through your earth line, back up this way through. See the arrows going up into house 2, up into house 1, all the way up there like that. So, and then if you throw in loss of supply neutral in house 1, can cause a voltage rise in house 2 and house 3, and then it becomes a TNS system. So we go up here, if we take out the main neutral, and as you can see that from the video that we've done of the power board of the 3 houses, you can, when we take out the main neutral, we see that we do get a voltage rise that can happen all the way along here, all the way down to house 3, up through your main earth, up through your TNCS to your main neutral link, and then up to your solar. And this is what causes your solar fires and your inverter problems that you're having with your solar systems, that all your alternative supplies, all your renewable energies, if they're tied into this protective earthing system, you're going to have major issues. And so we're going to look at that a bit later on. And so here again we've got loss of the main M.E.N link in house 1 can cause a voltage rise in house 2 and house 3, and again it becomes a TNS earthing system, because why? You've lost that there. See note 4, you've lost that link. And this can happen because of corrosion. There's lots of things that cause the earth stake down here. You can whippersnip that off. The water pipe bond can come unattached. There's lots of things that can happen there. And one of the biggest problems that you have with your this earthing system, the TNCS, is reverse polarity. And reverse polarity happens up this end of the architecture. It's something that happens out in the utilities area in the street, the poles or the transformer or something like that. But if you think about reverse polarity, think about that neutral now is inactive, then all these are livened up to 240 volts all the way through. And there's been a number of recorded accidents that have happened because of that. So let's go back over here and we'll look at note 5, which is your main earth and your main neutral faults. They're upstream of the RCD. The RCD will provide no protection at all. And that's with all the main earth, loss of main earth, the loss of main neutral. They're up here. They're all up here, or they're all balance between your live there and your TNC neutral. And you have to have an imbalance between those two on that line there to trip the RCD. And if you see that what we've just been talking about, they're here, they're here, they're over here, they're over here, or they're up here, in your solar. They're not down here, this end of the whole thing. So whatever you do up here with your solar is not going to matter down here, because it's not going to give you any protection. It's just ludicrous to think that putting a solar system up here is going to be isolated by this product down here, this RCD. So let's go and have a look at lightning strikes with your TNCS earthing system. Lightning strikes, look, that's note 6 there. If you had lightning striking the ground here, all 3 houses will get a voltage rise all the way up. And the biggest thing that I find with this is all your surge protection, all your lightning arresters and everything like that will only add to the damage. They will just, once the power's coming up this way, as I can see the arrows going, the lightning strike happens here, and the power is running along all these things. See the arrows going up, and if you've got surge protection down here, or up here, or up here, they're just varistas. They're just going to pop, and that's going to drag in, and you're just going to get a super overload and a brownout. It's going to be like a bad situation. So your lightning, anything to do with your lightning should have a separate true earth connection, not connected to your PE earthing system. Note 7 is your water pipe bonding, not required on PVC piping, which is your oiling mode, and that's what these ones here are. There's your note 7. There's no external taps that are earth. There's no point, because they're all isolated, and that's why we use this term up here, island modes. So we go down and we have a look at note 8. We've got soil resistivity, which is high resistive earthing from H1 to H2. Now, you'd have to have at least 15 meters between this earth stake and this earth stake, just in practicality. And so I've just given it a typical value of 6,000 ohms between there and there. So between this earth stake and this earth stake, you've got a high resistive earthing. There's no low impedance earthing, or the only low impedance earthing that you've got is this line here, all the way up there like that, and then down here to your earth stake, which is typically 2 ohms. But then the problems that we've just been through, like with the main earth, the main loss of neutral, reverse polarity, all the other problems, they come down here and they turn into a high resistive earthing problem, and that goes down through there. So if you've got, say, 6K here, then the operation of your RCD down here is going to be restricted. And down here, if you look at H2, we've got between H1 and H3, we've got 10Ks. So you're looking at, your resistivity is geographical. So you look at your soil types, your sand, your wet, your rock, whether it's rained in all those 4 areas, it just adds to the whole thing. So then we go down to our last note, which is island mode. There's no true earth, and M.E.N relies on a true earth connection. And the M is the multiple. They want multiple true earth connections. And this is compromised. And so when you go into this island mode, it's probably a TT earthing system. So it's if you go back up here, it's none of these 3. You look at your TN earthing system down here. If you get rid of your water pipe, your gas pipe, and just have your earth stake, then you've got no earthing points inside this house here, like in your wet areas. And combine that, as I said before, with your building codes and your wet areas, all the fiberglassing that they do with wet sealing and everything like that. So you've lost, in modern day housing, your basic safety of the TNCS earthing system. Thank you for your time.